Hello, this is Susan Poss. I'm an instructor at Spartanburg Community College, and I'm working in Chapter 7, talking about rational expressions, and that root word for rational expression is the root word ratio, and that means that we're going to be talking about things that are in fraction form. So lots of things going on here with numerators and denominators. First thing we need to talk about is remembering that the denominator of a fraction cannot be 0 because division by 0 is undefined. So if we took 5 and divided it by 0, we would write that the answer is undefined. Whatever we had, negative 17 divided by 0 would be undefined. However, if we have it the other way with the 0 on the top and some number on the bottom, then that is actually equal to 0. So keep that division by 0 is undefined in your mind, because that's the first thing we're going to be looking at here is when you're working with algebraic expressions that are rational in form, you may end up having a variable in the denominator, as you do in this first one, 5 over the denominator 3x minus 1. So we need to determine what value for x would cause that denominator to equal 0. So that becomes step number 1. You take the denominator and you deliberately set it equal to 0 and solve for x to see what would cause that to happen. What would cause this 3x minus 1 to actually equal 0? And of course you can see I'm going to add 1 to both sides to isolate the variable term, and then dividing by 3 on each side, I come up with x equals 1/3. So I just solved the equation. That was step number 2. Let me show you why that x equals 1/3 is a problem. So here's the original expression, 5 sitting over the denominator 3x minus 1. If I insert the value 1/3 for x, watch what happens. So on the bottom, the multiplication has to be completed first. 1/3 of 3 is 1. And then in the denominator, excuse me, I'm going to finish that next. And you can see I end up with a 0 in the denominator. And we said just a minute ago that that is undefined. Okay, so that's what we're going to be doing when we're looking for restrictions on the variable. Each time you're going to be setting the denominator equal to 0. To see what happens, see what values for x would cause that denominator to actually be equal to 0. So here I go again, step number 1. I'm trying to figure out what the restrictions are. Take that denominator, set it equal to 0. You will notice that this is a second degree equation. And the way that we learned how to solve this in Chapter 6 was by factoring the left-hand side. So you see we have everything on one side, 0 on the other. We're now looking for two numbers that will multiply to give me 6 and add to give me 5, or maybe subtract to give me 5. It's tempting to put in a 3 and a 2 here, both negative. But you'll notice on this last times last, that does not produce a negative 6. It produces a positive 6. So those aren't going to work. Since this is a negative 6, we know that the two signs are going to be different. So I'm going to put in 6 and 1 and place the minus with the 6 and the positive with the 1. And I think you'll see outer product positive 1, inner product negative 6x, I'm sorry, I forgot the x. That's going to give us the negative 5 in the middle x, negative 5x in the middle, and here's the negative 6x on the end. So that looks good to me. And remember, when you're solving a second degree, you're expecting two answers at most. And of course, solving here, one of my solutions is 6, and the other is negative 1. So I solved the equation. And now I know that x cannot be 6 and it cannot be -1. So those are my two restrictions. And again, if you go back here, I won't belabor this, but if you go back up here and you insert into these positions for x, either one of those numbers, I'll do one of them and you can check the other one. Let's do the -1. That'll probably be easier for me to work with. And I'm really only interested in the denominator. Of course, you can see on top it's going to be 1 minus 4. On the denominator, it looks like I have 1 plus 5 minus 6. Let me come on down here and finish that. So I have a -3 on the top, and I have a 6 minus 6 on the bottom. And of course, that 0 on the bottom causes this expression to be undefined. Now, I only checked it there with the -1, but the same thing would happen if you plugged in the +6. And here's an example of one where there are no restrictions. So number 1, I'm going to set the denominator equal to 0. And when I try to factor this, it will not factor. Because that is the sum of two squares. If I put a -6 minus 6, that would give me the +36 on the end, but it also gives me a -12x in the middle when I combine those like terms. If I make them both +6, the same thing happens. I end up with a +12x in the center, which the original equation didn't have. Later on in this course, we'll look at solving this a different way. And when we take the square root, we will notice that we're going to run into imaginary numbers. Some of you may remember imaginary numbers. So this one has no restrictions. And another example that I might give you is any fraction. Let's say this was an x plus 3 in the numerator with a 5 on the bottom. So you cannot change that denominator 5 from anything but a 5. It's a fixed constant value. So when you have examples like that, where you have just a constant number in the bottom, those are also examples where there are no restrictions on the variable because there is no variable in the denominator. All right, that's a good place to stop for